Hello, my dear students. Today we are in lecture number 23 of chapter 2, electrostat section. My dear students, today we will start with types of capacitor and their capacitance. How we can find capacitance. In very detail, we have studied about the capacitance, what is capacitance, is SI unit, etc. I am B.S. Pandey. My dear students, when we talk about the types of capacitor will have three capacitor. One, parallel plate capacitor, second, cylindrical capacitor. This parallel plate capacitor, my dear students, hardly you will find in electronic circuits. Cylindrical capacitor you can see even in your household circuit, okay, like in electric fan, in your water electric motor, etc. Third, it is the spherical capacitor. Actually, these all are the structure-wise name of the capacitor. My dear student, this spherical capacitor also you will find hardly, okay, to see. Now, we'll start how to calculate mathematically the capacitance of this capacitor. The parallel plate capacitor you will find is very famous, and you will have to solve the number of questions over this one. Cylindrical and spherical capacitor, there's only one question from each cylindrical and spherical capacitor in your NCERT. And this cylindrical and spherical capacitor is not very much famous. That is this question, capacitance of cylindrical or the spherical capacitor, I think have not asked in board examination to derive, okay. But parallel plate capacitor, and the one very important case, capacitance of parallel plate capacitor after insertion of dielectric. This is the very famous question, my dear students. So we are going to start the capacitance of parallel plate capacitor, but we are not introducing any medium. The medium will have, it is only air, okay, my dear students. So look at here carefully. This is parallel plate capacitor. Suppose this is the structure. I'm not drawing here the three-dimensional picture, because you might be confused. But let me try another very simple thing. This is almost three-dimensional but not perfect. Now you have to focus over the certain thing. This is the parallel plate capacitor. I am connecting these two plates with the battery to provide the potential difference. Okay, this is positively charged section, this is negatively charged section. Positive charge will accumulate over here, and the negative charge will be deposited on this face of the plate. Here, what are the things we'll have? The important thing, D will be the separation between these two plates. If these are the two plates, so this is the separation between two plates. A is the common surface area. Remember, A is the common surface area. Here, A, we are using the derivation. Here, we have started for capacitance of parallel plate capacitor. Okay, A, common plate area, common plate area. D, it is the separation between two plates. Okay, D, that is the separation between these two plates. It is the small d, we are representing with the small d. Okay, Q will be the amount of charge on plate. Okay, you can use the sigma also, but here in derivation we will not have the sigma. That's why I'm not writing here the sigma. This battery will provide potential difference delta V, or this can be also written as the V. This will give you the potential difference. Remember, my dear students, if in examination you have to ask to derive the mathematical derivation, you don't write in very lengthy language, let us consider A is the common plate area, blah blah. You have to just give the legend. Okay, like this one, you write A common plate area, okay, D separation, etc etc. You don't have to write in very lengthy language. You are giving examination of physics, not the examination of history and geography. Okay, you don't require to just explain too much. You have to give only the concept what you are having. Okay, now my dear student, as we have studied, electric field will be established between these two plates. Electric field from here to here will be established. Okay, what is the medium between the plates? Here the medium between the plates is air. Okay, air. The formula will derive that will be applicable for the medium as air or vacuum. So here the air will be the medium between the plates of capacitor. Now, how to find the capacitor? You have to remember the steps. 3 steps you have to follow. First, you will apply Gauss law. Okay, first you have to apply Gauss law. Then second, after applying the Gauss law, you have to find the potential difference. Potential difference. Remember this step I'm giving you, you have to apply this step for each type of capacitor. That will simplify or make your work easy. Potential difference. And the third one, okay, so the third one is to find the capacitance. Okay, finding capacitance. How? Q equals to C delta V. You have to use this Q equals to C delta V to find the capacitance. Since this is the not the part of derivation, this is the key I'm giving you. That's why I'm rubbing this one. Kindly note down. Okay. Yes, this one. Now, my dear student, as I told you to find the to apply the Gauss law. So applying Gauss law or the Gauss theorem. To apply the Gauss theorem, you have to enclose the plate. Okay, Gaussian surface. Enclosing the plate, remember, just near the plate I am drawing a Gaussian surface by this black marker. It means the surface area of enclosed Gaussian surface, it will be equals to the area of the plate. Remember, area of the plate. The Gaussian surface is equals the area of Gaussian surface equals the area of plate. That is the common area of plate. Now I'm applying E dot dA is equals to E dot dA, that is the electric field and area. It is equals to the Q enclosed by epsilon naught. What is the Q enclosed actually, my dear student? So the Q enclosed is nothing but the enclosed charge by this Gaussian surface. And how much the enclosed charge? The total charge Q. What we have taken here, this total charge will be enclosed by this Gaussian surface. Now we can find the electric field from here, and E will be here the dA the elemental area. Integrating this elemental area, you will get the total area of the plate. So we can write here the E equals to Q by A epsilon naught. Equation 1. I don't think that this is the very difficult one. Now look at it. The second step was to find the potential, as I told you, okay, to find the potential difference between the plates. So what you will write here, the potential, to find the potential difference, dV. Remember the steps I am writing here, you have to follow. dV is equals to E dot dr. We have studied E dot dr. Remember this was the minus, we have taken here the minus, but to represent your minus we used to write, again I'm writing this one to recall you only, this is not the part of your notes of this derivation. dV, that is the V final minus V initial, okay, is equals to minus E. Here the R final minus R initial. But if you're writing V I minus Vf, then you have to write E Vi minus Vf. Okay, minus will compensate. It means V from A V B, it will be E here R A R B. Okay, R A R B, in such a way. So we'll use the limit initial final, and here we will use the same limit initial final for the position vector. Okay, my dear student, so I'm rubbing this one. dV is equals to E dot dr. Now I'm not using minus, you know very well the reason behind that. Okay, so we have to find the potential here, the electric field from equation 1. We can write here Q by A epsilon naught, Q by A epsilon naught dr from equation 1, and dV. Now I'm integrating. Potential will be, we are starting from this point, the potential will be 0 to V, it will move from 0 to V. For the potential here, the 0 to separation will be D, and then we will have V is equals to Q by A epsilon naught times D. This is the equation 2. Now the third step was to find the capacitance. Now capacitance, and this capacitance Q we can write here the CV, that is the delta V. So it is C times, and V is what, Q D by A epsilon naught, and the Q will be cancelled out. Then we can write here the C is equals to epsilon naught A by D. This is the capacitance of parallel plate capacitor. Epsilon naught A by D. Epsilon naught, it is the already we have studied. Epsilon naught is the absolute permittivity of the medium. A common plate area. D is the separation between the two plates. Now students, use on the basis of this formula we can correlate, or we can study the factor that will affect the capacitance, okay, of parallel plate capacitor. Factor affecting capacitance. What is the factor? The first one, epsilon naught, that is the medium. Okay, medium, that we'll study in later on this in this topic only, that is the dielectric. Okay, that will be the medium. Of course, you can see this medium will change the capacitance if this epsilon naught, since the epsilon naught is the value, minimum value, and that is for the air. That is for the air. That's why this capacitance is minimum one. If you will use a dielectric, that will increase the value of epsilon naught, that is the relative permittivity, then we'll have the more capacitance, that C will increase. We will study the second one. The second one is the area. So C, you can see here, directly proportional to area. When epsilon naught, it is already constant, and D is constant. Now third one, C inversely proportional to D. But when epsilon naught, that is the medium, you can see the epsilon and area will be constant. So in this way, the capacitance of parallel plate capacitor changes or affect by the different quantities. Now, my dear students, we are moving for the next derivation. It is the capacitance of cylindrical capacitor. Okay, the number of question you will find in assignment even, and in NCERT also you have to solve such question on the parallel plate capacitor. So the next one, we are moving for the cylindrical capacitor. So you can write the question, derive mathematical equation for the capacitance of cylindrical capacitor. Okay, cylindrical capacitor. Here I am drawing cylindrical capacitor. The two, this is the very long, remember, and this length L is so long in such a way, this length is much larger, this L is much larger than the radius of two cylinder. Here the two cylinder we are using, suppose the radius is A inner and the outer is B. Now the two cylinder here. Okay, this is the inner cylinder and this is the outer cylinder. On inner cylinder, let us deposit a charge positive by any means or method. We have connected this inner cylinder with the positive terminal of the battery. Now over this cylinder, a negative charge is deposited. It is okay on the outer cylinder. Now if we'll take a Gaussian surface, this is the Gaussian surface, dotted one I am using, of radius x. X is the radius of Gaussian surface. Okay, now the cylinder is inside. The condition what we are using here, L is much greater than both the radius A and B of both the cylinder. Okay, A and B. Okay, now my dear student, here first step we are going to find out A and B. I hope you should remember A and B are the radius of two cylinder respectively. Okay, two cylinders respectively. Now first we have to apply Gauss law. So applying Gauss law, what will write? Applying Gauss law, this actually a Gaussian surface has the shape of cylinder, and E dot dA will be written as Q by epsilon naught. Okay, integrating this value, E dot dA. dA is the surface area of Gaussian surface, and the surface area of Gaussian surface, the radius of Gaussian surface is x, so the 2 pi x times L, and this is equals to Q by epsilon naught. So E can be written as Q by 2 pi epsilon naught x times L. This is the equation 1. Now, what was the second step? Recall? Yes, second step was to find the potential. Now, the potential difference between two cylinders. So, the potential difference we can write here as dV is equals to E dot dr. So the dV integrated at the V, and E is from equation 1, Q by 2 pi epsilon naught x times L into dx, or the dr. You can write here the dx or dr. I think red one is not better, has no better visibility. Dx. Okay. Now integrating, this has been integrated already, so the dv integrated to get v. Now this q by 2 pi epsilon naught L is constant. What will have? 1 by x dx. Okay, 1 by x dx, and we have to integrate this 1 by x dx from a to b. Okay, so the positive terminal at a and the negative one is b, so from a to b. Now integrate it, you will get the result. V is q by 2 pi epsilon naught, 2 pi epsilon naught L, and this is 1 by x dx will be ln x. Okay, this is natural log x. Now this is the second equation. Third, to find the capacitance, you have to apply for capacitance. You have to write Q is equals to CV. Okay, Q equals to CV, and then C and V, it is Q by 2 pi epsilon naught L. I think we should put here the limits also. L ln x from A to B. Q is cancel out. Now the C, it is 2 pi epsilon naught L. It will be above 2 pi epsilon naught L divided by ln B, A to B, that is B by A. And this is the capacitance of cylindrical capacitor. I hope, a student, you understand very well how to find the capacitance of this cylindrical capacitor. Okay, now we'll move for the next derivation, that is the capacitance of spherical capacitor, my dear students. Okay, we should grab this one. Now, spherical capacitor. Okay, so this one is the spherical capacitor. The two concentric spheres, that is the cell, metallic, the radius A and the radius B. Outer cell is being earthed. Okay, if this is positively charged, then inner one will be negatively induced charge deposited, the outer positive will be goes and it will be neutralized. Now my dear students, we are taking here the Gaussian surface. The radius of the Gaussian surface will take here the x. Okay, here the x. What we have to do first? Here I'm not writing A the radius of inner cell, B the radius of outer cell, x is the radius of Gaussian surface charge, ये वो ना. Okay, so here applying Gauss law, we can write E dot dA is equals to Q by epsilon naught. Okay, now E dot dA, remember, so the E and dA, what dA is the elemental area of this Gaussian surface, and the total area will be the 4 pi x square. Okay, 4 pi x square is equals to Q by epsilon naught, this one. So you can find here the electric field as 4 pi epsilon naught x square. This is the first equation. Now what was the second step? Yes, the second step was to find the potential difference. Now the potential difference. So the potential difference Q is equals to, the potential difference V or the dV equals to E dot dx integrated V, it is E Q by 4 pi epsilon naught x square times dx. So the constant will be taken out. Q by 4 pi epsilon naught, it is the constant 1 by x square dx from A to B, and this will be equals V is equals to Q by 4 pi epsilon naught, and 1 by x square integration will be minus 1 by x from A to B. So the Q by 4 pi epsilon naught minus 1 by B plus 1 by A. I'm writing a little fast because these are the very simple mathematical calculation. You will not confuse yourself. V, it is Q by 4 pi epsilon naught. This can be also written as the KQ. Okay, 1 by 4 pi epsilon naught can be written as the KQ. So it is Q by 4 pi epsilon naught. It is AB. Okay, A, B, and then B minus A. This is the second equation that we have written here, the potential difference. Now capacitance. So the Q is equals to CV, Q equals to CV, and we can write here other Q is equals to C times, and V it is Q by 4 pi epsilon naught B minus A by AB. Cancel out, so the C will be 4 pi epsilon naught times AB by B minus A. Okay, my dear student. Or this can be also written as the C is equals to AB by K times B minus A. This is the another form of potential. Okay, the capacitance of a spherical capacitor. Little bit change, you will find the questions that you will have to derive the capacitance of isolated capacitor, that is the isolated. Okay, my dear students. So next lecture will start from here only, how to find the capacitance of isolated capacitor, force between the plates of capacitor, and then we will start the concept of dielectric. Okay, my dear students. So this is all about the today lecture. Thank you very much.